Hey everybody, this is Larry. This is day 26 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Today's poem is our boundary paths. Yeah, hit all the like buttons, all the stuff. I am not going to do the extra poem that I usually do today. I got home pretty late, just kind of hung out with a couple of buddies. But yeah, let's take a look. So there's an n by n grid of a board. The board is at start row, start column. You're allowed to move the board in one of the four adjacent. Return the number of paths to move out of the grid boundary. Since numbers can be okay. Yeah, I mean, I'm gonna rename these a little bit just to the R and C, just because it's, I don't know, it's more meaningful to me, rows and columns, especially since they give you stuff in rows and columns. And this is gonna be a dynamic programming problem. We just kind of have to, yeah, I mean, I guess this is a dynamic programming week. First of all, there is this like modulo thing, so let's do it before we forget. I usually sing a song, something like mod before I type it out. And yeah, and otherwise, I think there are a number of ways you can do it, but yeah, I mean, they're all going to be dynamic programming variations. The way that I like to do it is probably I don't like to use the term bottom up for this one because that's just a little bit confusing. I think the way that I would say is, yeah, like maybe tabulation or just almost sort of simulating it or in parallel is how I would phrase it. But we can also do it the other way, to be honest. It's not, we could do it top down, and that maybe is straightforward. It's just maybe we have a count, right? So we have the current X, the current Y. We don't really need anything else from the R and C, but we have maybe moves, right? For moves left. Yeah. And if you kind of look at the constraints, well, there's going to be 50 times 50 times 50. So that should be good, right? 50 cubed should be good. You're only going to make one of the four directions anyway. So yeah. And then, yeah, basically if X is less than 0, or y is less than 0, or x is greater than or equal to r, or y is greater than or equal to c, then we return 1, right? Because that means that this is one way to be outside. Otherwise, if moves is equal to max move, that means we cannot move anymore, then we return 0 because we're done. Otherwise, we just total is equal to 0. Total, we add count, we want to go, I guess in this case, actually down 1. We can also go to the right 1. We can go up 1. And we can go down, left 1. But basically, just up, down, left, right? And then we return total. Of course, so that we don't forget the mod, we should probably mod some of this. We'll just mod here. There's only 4 additions, so that means that it'll be only at most 4 times mod, which is okay, at least in Python, because actually more than that may be not good depending on language, but that just means adding more mod in between, so that should be good. And now we just have to count from start row, start column. Let me double check that this is 0 indexed. Right, we don't need this mod, but is it start row, start column? Is that 0 indexed? I guess so. This is 0, 0, so that should be good. Yeah, so then now we just, well, give it a spin. Of course, this is not gonna actually run for anything bigger, just because, well, we branch out 4 times for each cell, so that's going to just add up very quickly. So of course, we take a look at the input, and we know that x can go from 0 to r, y can go from 0 to c, or technically -1 to, if you want to be more precise. And except for that, obviously, when that happens, we'll just early return the 1. And moves is going to be 0 to max moves, or move. Is that programmer? I think that's programmer. But in any case, yeah. Then we could do the caching thing that we always generally do on this channel. Again, feel free to kind of abuse, or not abuse, adjust to whatever you want. But yeah, did I mess that up? I think I messed this up. Yeah, and yeah. And the idea here is just that when you get the same input for the count function, every same input will give you the same output. So that means that we should just save it, right? Because we already have calculated it otherwise. And that's pretty much it, really. And then otherwise, we want to set it to true. And that's good. Yeah, whatever. One extra operation, too lazy. And yeah, what the hell? But maybe we want to try something big, like 50, 50, 25, 25, or something like that. And yeah. That actually is taking longer than I expected, but I think that's just Leetcode, not the thing. But yeah, looks pretty good. 1396-day streak. Pretty decent streak. What did I do last time? Why is that so much slower? That's actually surprising. Is it surprising? I don't know. I don't know why it's so much slower. But I never done it top down, I guess. But yeah, but this is like, if you think about it in brute force kind of way, it is actually kind of brute forcey, right? Because like I said, you just keep track of the current moves and the number of moves that you've made, so that you can, and you can also count up, count down on the moves. It's, that's just about how you're modeling it. Yeah, I think also I just want to say that this is one of those first problems where, especially top down, it is not symmetric, right? I mean, I guess you can make it symmetric with the base case, but it seems pretty tricky. Like, because you can count outside in or something like that. And, but yeah, so you have to kind of start in this way. So yeah, so that's kind of one thing to kind of take a note on if you want to curious about. I'm not gonna lie, this video is a little bit low effort. I'm just really tired. It's 1:45 a.m. Maybe I should do it earlier, or like tomorrow morning or something. I don't know. Let me know what you think. Let me know how you did. Let me know how you enjoyed this problem. Weekend is here, everybody. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.